You interact with massive, sprawling apps every single day, right? But have you ever actually stopped to wonder how they scale up instantly and somehow almost never crash? Well, welcome to our explainer on Kubernetes. It is the ultimate orchestrator, literally shaping the modern web.
Section 1. The Cloud Orchestration Standard. So, what exactly is it? Kubernetes is an open-source system built to completely automate how modern software gets deployed, scaled, and managed across massive networks. It basically handles all the heavy lifting of managing complex apps, freeing developers up to do what they do best, which is build.
Section 2. The meaning behind K8s. To really get a grip on this standard, we need to demystify its common industry shorthand, because you are going to see it absolutely everywhere.
You know that abbreviation K8s? It's actually just a super simple numerical contraction. The 8 literally just stands for the exactly 8 letters sitting right there between the K and the S in Kubernetes. Knowing that little piece of trivia instantly makes you fluent in developer speak and honestly strips away a lot of the intimidation factor.
And the name itself? It totally gives away its purpose. In ancient Greek, Kubernetes means helmsman or pilot, and that's exactly what this software is. It's a pilot perfectly steering your incredibly complex workloads across the stormy, ever-changing seas of the cloud.
So where did this absolute powerhouse come from? Well, Google originally built it to manage their own massive global workloads. But instead of keeping it locked away as a proprietary secret, they open-sourced it. Today, it's maintained by a huge worldwide community, and the trademark is securely held by the Cloud Native Computing Foundation. It's wild to think it evolved from an internal tool into this massive collaborative triumph.
Section 3. Anatomy of a cluster. Let's look under the hood and see how this helmet actually organizes hardware.
At its very core, Kubernetes takes individual computers, whether they are bare metal physical servers or virtual machines, and perfectly assembles them into one single unified cluster. It runs your workloads inside highly efficient, isolated environments we call containers. And to pull all this off, it relies on background runtimes like Containerd and CRIO. Those are just the underlying pieces of software that actually execute the containers.
Section 4. Control planes and nodes. To manage all this chaos, the architecture splits into two primary internal components. The cluster divides its labor really cleanly. On one hand, you have the control plane. This is the management brain, making the high-level, global decisions for the entire system. On the other hand, you have the nodes. These are the muscle. They're the actual hardware environments where your apps actively run and execute their tasks.
Now, to actually give orders to this system, developers use some essential tools, primarily kubectl and kubectl. Think of these as your interface to the platform's REST-based API. Basically, they're the communication bridge, translating your human commands into actions that the cluster can actually understand.
Because this setup is so incredibly flexible, it's become completely ubiquitous. You'll find it across all major public cloud vendors and independent software vendor distributions. And this is exactly why real-world demand is just exploding right now. For example, companies are aggressively hunting for senior Java microservices developers right now to modernize digital banking using Kubernetes architecture. If you look at places like Arlington, VA, there's a massive demand for cleared engineers, with tons of job openings for junior DevSecOps engineers and senior systems architects to build secure clusters. Developers are constantly swapping integration tips, too. In fact, there are 159 recent blog posts entirely focused on cloud computing and this architecture, including 56 ordered by Hacker Noon reader engagement, breaking down things like DevOps efficiency, multi-channel notification systems, and video conferencing API integrations. Because at the end of the day, effective integration is absolutely crucial for streamlining workflows, improving data accuracy, and enhancing overall system functionality.
So, this brings us to a big question. As cloud workloads continue to scale massively, is Kubernetes the undisputed standard for modern data centers? While some people will definitely argue the learning curve is pretty steep, the industry consensus is loud and clear. It's not just an option anymore, it is the standard. Mastering this architecture really is how you future-proof your infrastructure. Thanks so much for joining me on this explainer. Keep learning, and I'll catch you next time.